everyone. My name is Dipali, and if you're a civil engineer student and want to prepare for the GATE examination or any state examination, then this channel is for you all. So in today's session, we're going to cover up some most important GATE question and with their detailed solutions. So let's start it. All right, so we are going to prepare for the GATE most important questions. It will help you a lot in your examination. So the first question we have here is, okay, so the question here is a concentrated vertical load of 3000 kilonewton is applied on a horizontal ground surface. The points P and Q are at depths 1 meter and 2 meter below the ground respectively along the line of application of the load. Okay, so considering the ground to be linearly elastic, isotropic, semi-infinite medium, the ratio of increase in the vertical stress at point P to the Q. Okay, so I want to show you one thing here is, first of all, it's a question of the soil, right? Okay. Now, the second of all, this question belongs to the Bosnick's equation, right? So if you know the Bosnick's equation, you can easily crack this question. So what is the Bosnick equation? Suppose we have a surface over here and Q load is applied. So we need to find the vertical stress at the Z depth and which is our radially distance. So basically if to find the vertical stress at P, this equation is helpful. Now how we find the vertical stress? It is nothing but 3 upon 2 pi Q by Z square 1 upon 1 plus R by Z whole square power 5 by 2. Okay, so this is the equation. Now, looking to the question, what is the given data we have? The given data we have is the vertical load Q is 3000 kilonewton, right? Okay, now the one very important along the line of application of the load. That means along the line of application. So here we can say that the radial distance, है ना? The radial distance is actually 0. Okay, so this makes the question very, very simple. Now, this whole part will be 0. So again, now we need to find at P and at Q. So that means 3 upon 2 pi. Q will be same for both the points, right? Because the vertical load applying is same again. Then the Z is, so Z is 1 meter for P and Z is 2 meter for Q, right? So it will be 1 square upon 3 upon 2 pi Q upon 2 whole square. So it will be nothing but 4. So your answer is 4. All right. So if you want to take the screenshot, you can take it right now. Okay. Moving on to the next question, we have question number 2. See, what the question say here is a semicircular bar of radius r, all right, and a vertical plane is fixed at G point. So G point we have fixed as shown in the figure, all right. A horizontal load of magnitude P is applied at H. The magnitude of axial force, shear force, and bending moment is asked at Q, which is making a 45-degree with the center, all right. So we need to find all the forces, axial force, shear force, and the bending force, right? How we will find? See, so we have this semicircular bar. One end is fixed over here and the P load is applied. Okay, so this is the data we have been provided in the question. Okay, one more thing here we have is it making 45-degree. Okay, so this is R. See, suppose we have this right angle triangle, right? This is an R, this is 45-degree. So it will be nothing but R by root 2 and R by root 2, right? So first of all, talking about the bending moment, right? What do you mean by the bending moment? For any section, we need to find the bending moment. That means we need to find the summation of all the moments on the either side of the section. Let's talk about this left section of this left side of the section. Now we have the P load and corresponding to the P horizontal load, this will be the perpendicular distance, right? So this will be R by root 2. So nothing but PR by root 2 is the bending moment. So obviously the B option is wrong. Okay, now let's talk about the axial and the shear force, right? Again, we need to draw this semicircular bar. One end is fixed and one have the horizontal force P. Okay, again, this point, okay, this is making 45 degree. This is our Q. So at this point, we need to find the axial force. So let's say this is our half part. This is the P load. At this Q point, there can be a 1A axial force and there can be an S shear force. So I am actually denoting the axial force by capital A and the shear force by capital S, and they are making the 45-degree angle with the x-axis and with the y-axis. Okay, so now resolving all the force component, we can easily find out the A and the S. So first of all, summation of all the x is 0. Okay, so it will make A by root 2. It will make A by root 2. And in downward direction, it is S by root 2. And here will be S by root 2. Okay. All right. So A by root 2 plus S by root 2 is P. This is the first equation. Summation of Fy equals to 0. We will given then this is A by root 2 minus S by root 2 is 0. That means A is equal to S, and which is nothing but P by root 2. So by seeing the options, the A option is correct. So if you want to take the screenshot of this solution, you can take this. It's a very important question of how you actually resolve the components of the forces and find out the answers. Okay, so now let's talk about the third very important question of steel. Okay, so a weld is used for joining an angle section we have been provided. So we have this angle section 100, 110, okay, and thickness is 15, okay. Now, the permissible stresses in the angle is 150 and the permissible shear stress through the throat of the fillet weld is 108 MPa. Then we have some detail of XYY and the angle. All right, so this is whole data we have been provided. So before starting this question, you need to find out a very important trick you need to remember over here is in the steel, this type of question, if we are using a fillet weld at, let's say, L1 and L2 distances, so the relation between L1 and L2 is Y2 by Y1. Now, what is Y2, Y1? This distance, the distance from the CG is, so this is Y1 and this is Y2. So one of the relation we will be using is this. Okay, so Y1 is being provided to us here is 28.4 mm, right? And the Y2 will be what? This is complete 100. So 100 minus 28.4. So let me calculate 100 minus 28.4. It will be 71.6 mm, right? So L1 by L2 is nothing but 71.6 divided by 28.4, right? So it will be nothing but 2.52. So this is number one equation, very, very important. All right. See, now the next point we have is the permissible stress in the angle. So the permissible in angle we have been given here is 150 MPa. 150 MPa, that means 150 Newton per mm square, right? Now, the angle cross section is also given to us 1903 mm square. 1903 mm square. Okay. So what is the strength strength of angle. So strength of angle is nothing but stress into area, right? तो ये मुझे कितना दे देगा 150 into 1903, it will give me Newton. Okay, so 150 into 1903, it will give me 285.45 kilonewton. Okay, now another point over here is for the fillet weld, what is effective angle? Yani ki the total area, how it will find out the throat thickness into total length. So the size of the fillet we have been provided here is size of fillet. That is 5 mm, and we have been given that it is 0.7 times the weld size, right? So it will be nothing but 0.7 into 5 into L1 plus L2, and it will be equal to, and the permissible stress is provided on the section of the throat is 108. So that means the strength we have given, so 285.45 kilonewton is actually 108 into 0.7 into 5 L1 plus L2. But now you need to understand the dimensions, units very well. Okay, this is in kilonewton and this will provide me in actually Newton. Okay, so it is multiplied by 10 to the power 3, right? And this is in mm, so 10 to the power minus 3. Okay, all right. Then this L1 plus L2 value will be, there is the angle, the location of the permissible shear stress on the section of the throat here is 108. So for throat, the permissible stress is 108 MPa. Okay, so now 108 into 0.75, 0.7 into 5 into L1 plus L2 will give me how much strength? The strength has already been calculated, that is 285.45 into 10 to the power 3 Newton, right? So this L1 plus L2 will be in mm actually. Okay, so let's calculate with the help of calculator. 285.45 into 1000 divide by 108 into 0.7 into 5. Okay, so it will be 755.158 mm. Okay, now we have this 755.158 mm and one more equation. This is the second equation, right? What is the first equation? L1 by L2 is 2.52. So L1 will be 2.52 into L2. So 3.52, L2 is 755.158 mm. Then L2 is 214.53 mm and L1 will be 540.624 mm. Now in this question, it is asked to write in the nearest integer. So for the nearest integer, we'll say that L1 is 541 mm and L2 is 214 mm. All right. Now, the third very important question we have is, see, the water sample having the concentration of Ca plus 2, Mg plus 2 and CaCO3 as 100 mg per liter, 36 mg per liter and 122 mg per liter. So atomic masses are also given. Now we need to find the total hardness and temporary hardness. All right. See, if you do not know the very important concept related to the carbonate hardness and non-carbonate hardness and total hardness. So first of all, the total hardness is the milli equivalence of multivalent cations. So multivalent cations are what? That is Ca plus 2 and Mg plus 2, right? Then the carbonate hardness is the minimum of total hardness and alkalinity. Okay, so first of all, let's say calculate. So, and for the non-carbonate hardness, it is total hardness minus carbonate hardness. So now what is the question has been asked? It is asked about total hardness and temporary hardness. First of all, let's take a screenshot of this. The very important formulas of total hardness, carbonate hardness, and non-carbonate hardness. Okay, let's begin with the total hardness. So total hardness will be from the Ca plus 2 and Mg plus 2. Ca plus 2 concentration we have been given here is for 136. Okay, so it is 100 mg per liter and mg plus 2 we provided is 36 mg per liter. Now, first of all, tell me what is the Ca has a molecular weight of 40, right? And its N factor is 2. So its equivalent weight will be 20, right? So we will write down like this 20 into 50. Why 50? For CaCO3, the equivalent weight is 50. So we'll multiply by 50 plus, again, same for the magnesium, 36 divided by, for magnesium, it is 24, right? 24, it's its molecular weight, divided by 2, its N factor, so it will give the 12. So here it will be 12 into 50. So this whole will give the total hardness as mg per liter as CaCO3. So now let's calculate with the help of calculator. 100 into 50 divided by 20 plus 150, right? So we'll have is 400 mg per liter as CaCO3, right? Now let's talk about the alkalinity. Alkalinity, how we'll find out? So for the alkalinity, we should know the carbonate, bicarbonate, and oxide ions. So only bicarbonate ion has been provided to us as 122 mg per liter. So 122 mg per liter as HCO3 minus. Now, molecular weight of HCO3 is 61 grams, right? So an N factor is 1, so its molecular equivalent weight will be 61 only. So alkalinity will be 122 upon 61 into 50 mg per liter as CaCO3. So it will be 122 divided by 61 into 50. That is 100 mg per liter as CaCO3. Now, see. So we have the carbonate hardness, or we can say temporary hardness. So the carbonate hardness or temporary hardness is minimum of 400 mg per liter and 100 mg per liter. So minimum will be, of course, the 100 mg per liter. So this will be the carbonate hardness and total hardness is 400. Now, very important here is both calculate in a form of mg per liter as CaCO3 because it will helpful in comparing both the quantities. So you can take the screenshot of this very important solution, and hence the answer will be 400 and 100, option A. Okay, moving forward to the last and very important question, and this is related to the maths, right? So we have been provided a Fourier cosine series of a function. Now we need to find the numerical value of f4 and f5. That means the coefficient of cos 4x and cos 5x. First of all, what is the f of x provided to us? It is cos 4x, right? So important formulas required for this question here is that cos square x, right? It can be written as cos 2x plus 1 by 2. Okay, so with the help of this formula, we will solve this question. Okay, let's see how. So cos 4x can be written as cos square x ka whole square, right? Okay, now cos square x can be written as cos 2x plus 1 by 2 whole square, right? Now let's square this whole. We'll get 1 by 4 of cos square 2x plus 1 plus 2 cos 2x, right? Now again, we can see that cos 2x whole square plus 1 plus 2 cos 2x, right? So if cos square 2x is written over here, then cos 2x whole square can be written over here is cos 4x plus 1 by 2, right? So now you will easily understood how to write it down. Cos 4x plus 1 by 2 plus 1 plus 2 cos 2x. Now, so we need to find coefficient of cos 4x. So coefficient of 4x here is 1 by 4 into 1 by 2. That is 1 by 8. Plus, we do not have any cos 5x, right? So its coefficient must be 0. So what will be the answer? It is nothing but 1 by 8. And we need to write it in 3 decimal places up to. So it is 1 by 8. It means 0.125 is the answer. So thank you so much. I hope you like this session. And if you do, please do like and share with all your friends of civil engineering. It will be very beneficial for your learning. Keep learning. Thank you so much.